Hey everybody, it's Miss Reese. If you guys could have your graphing calculators out and your notes packet, we're on day 2, parent functions and transformations. I didn't want you guys to miss any more material just because I couldn't be here. So I'm here virtually, so hopefully this will be helpful for you guys. Again, I understand that it's very hard to learn from a computer, especially one that's not really able to interact with you. So any questions, comments, or concerns that you guys have about the material, please make time to see me on Friday or Monday before class, and obviously I'm going to go through and make sure you understand it. So day 2 is called parent functions and transformations. Transformations just kind of mean changing the way something looks, but not necessarily the value of it. And parent functions are just that. They're basically the original functions, and from there we can transform them. I will post some videos on the Unit 2 webpage, which hopefully you guys have accessed. If you haven't, it's on Canvas, and there's lots of good videos, and these videos will also be posted as well. So bear with me, as this is my second video ever being made with this material. So you'll see I have my little graphing calculator here, and then we're going to fill in some of these notes. But for the most part, you guys are going to do this with each other using your calculators. I'm just going to walk you through the first one. So a family of graphs displays similar characteristics. A parent function is the simplest function of the family. A transformation changes the position or size of the figure. Transformations can be applied to parent functions. So again, it's more of an investigation today, and then we'll talk a little bit more about how we can apply it. But that's what our goal is for today, is to understand the different functions. So the most basic function is our linear function. And I'm going to show you guys how to get all this information from your graphing calculator. All right, there it is. So I'm going to drag this over here. We'll first take a look at the table and how we do it. I already have mine set up for you. But the first thing we're going to do is press Y equals and just clear everything out to make sure that there's nothing left from our last test. So remember yesterday, or 2 days ago, our lesson about functional notation, how f of x is just a fancy way of writing y. And so that's why your calculator is in xy notation as opposed to your notes that says f of x. But again, it means the same thing. So f of x equals x is the same thing as y equals x. And remember, your x variable for your graphs are right next to the alpha button. So there's that. So you can graph it. And there's the graph. It's a beautiful graph. It's a increasing slope through the origin, it looks like there. And if you want to go ahead and graph it, you can. But what I would probably do is, why don't we go ahead and fill in the table first? And the way we find a table is to do second graph, and that's going to give us our table. Now you may have to scroll up and down to find the ones that are here. Mine just happened to be right here. So when x is -4, or my input is -4, my output is also -4. So we'll come over here and substitute in -4, and then I'll write -4, comma, -4, and put those in parentheses, like so. And then you can even go and plot that point. 1, 2, 3, 4, 1, 2, 3, 4, and make your point. And you're going to continue the same process. So I come back to my graphing calculator and fill in the rest. -2, -2. I'm starting to see a pattern here. Let me guess. At 0, what do you guys think it's going to be? That is correct. It is also going to be 0. At 2, we're at 2, and at 4, we're at 4. So again, fill in the table. I'm not going to do it just because it's going to be a mess and I don't want it to be too messy. Then we're going to plot our points. Boom, boom, boom. At the origin. Keep going. There we go. And let's go ahead and make a line through there. Let's see how well I can make it. Oh, look at that. Not bad at all. Oh, that's a ray. Let's just pretend that, or I guess we can make it, that there's an arrow at the end there. So the next thing that we need to look at is some of the characteristics. This is just a tiny, tiny bit of the characteristics, but we want to make sure that you get exposed to them. So we talked last time about domain and range, domain being the possible x values. Now I know some of you want to right away say the domain is -4, -2, 0, 2, and 4 because that's what's listed on our table. But for a continuous function that goes on forever and ever, it's more than just those points. So our notation for our interval notation would be -infinity to +infinity. And remember, infinity doesn't really exist. You can't put your finger on it, so we cannot include it in our interval. So that's why we have the parentheses, which means not included. With our range, again, I know you want to say that it's just these, but it's going up forever and it's going down forever. So in this case, our range is also going to be -infinity to +infinity. Now, this is just for the linear function. You guys are going to do your little investigation and determine for the rest of them what it's going to be. For my x-intercept, that's where it crosses the x-axis. You'll notice that the x-intercept is located at the origin right here. And in this case, it's also the y-intercept. So we've got 0, 0 as that as well. So before I let you guys go off and do this all on your own, I wanted to at least have you fill in the boxes. So we've got our quadratic function. That's the graph that you're going to put into your notes and into your graphing calculator to do your investigation. And then we've got our cubic function. And I think the next page is going to have our absolute value function. And for that one, I guess I need to teach you how to do that on your graph. You can find your y equals the absolute value if you clear that out and go to math and go to number. That first one right there, ABS, that stands for the absolute value, and it's going to give you your absolute value bars. So that's how you would put the absolute value one in. And let's see, 1 divided by x is our rational function. And again, that shouldn't be too hard for you to put into your calculator. The next part, again, is just exploring. You're going to change your graph from f of x equals x squared to g of x equals x squared plus 2, and tell me what happens in your calculator. Again, you guys can, oh, there's the answer. You weren't supposed to see that. But I want you guys to try it on your own. Again, I'll post all the answers and we'll talk about it some more. But hopefully this is a way for you guys to kind of figure it out on your own before I tell you what happens. And I hope that you enjoyed this little video, and maybe I'll start doing more of them so that we can do our notes at home and then have some fun during class time. So again, thank you guys so much. And again, email me if you're still confused on the lesson. I understand completely. But make sure that you're proactive in learning how to do it before it's too late. So hopefully you guys have a great weekend, or I'll see you on Friday if you want to stop by and just say hi. Otherwise, I'll see you guys on Monday. Thanks a lot.